Okay, assume that y is a function of x, so y is not just a constant, that's why they say that, and it's a function of x, so let's find dy dx. Let's find the derivative with respect to x, the derivative of y with respect to x. So, in this, remember, x is the main variable here, because that's how you tell. So, let's take the derivative. Well, you should pause it. You should pause it and do this on your own. Try it on your own. Anytime you're taking the derivative of x, you do it normally. Anytime you're taking the derivative of y, you do it normally and then tack on a dy dx. Alright? Alright? So you try it. Pause it? Okay, I'm going. First of all, the derivative of x is just 1. So I'll leave that as 1. Plus sine, I have a sine function. And I also have a y function. So I do have to use the chain rule. The derivative of the outside, which is cosine of y, with the inside the same, times the derivative of the inside. Well, if I took the derivative like it was a normal y, a normal x, then the derivative of x would be 1. So the derivative of y is going to be 1. But I'm also going to tack on a dy dx. And then I have to use product rule there. Whoops. I have to use product rule. PR. Okay, so first, that's x, right? First d second plus second d first. First d second, the derivative of y is just 1 times dy dx. Eventually I'm just going to write a dy dx. First d second plus second d first. Derivative of x is just 1. Okay, I'm going to simplify. Ooh, there's 2 dy dx's. I'm going to rewrite it and then start getting the dy dx by yourself. M and the d. Can you cancel out the x's here and here? No, you can't. This is not an x times a d. It's dx. It's a differential. We'll get to that later, but it's a single quantity. It's just a name. It's just notation. So no, you cannot cross out those x's. This dx is stuck together. This dy is stuck together. All right, now I'm going to solve for dy dx, and that I'll do first by I'm going to get the dy dx's to one side and then everything else to the other side. Kind of like letters to the left, numbers to the right. So I'll subtract x dy dx. I'll subtract that over x dy dx. And then I will subtract the 1 over. So that goes away. And what do I have to do? Now, it might not be obvious to some people, but this is just like an algebraic term, so I can factor it out normally. Let's see. So I'd have dy dx times cosine of y minus x equals y minus 1. Alright, so if I want to get the dy dx, so I factored that out, sorry. Let's think about that. If I multiply this back in, I get cosine times dy dx. If I multiply that back in, I get the negative x times dy dx. So that's factored out, alright? Alright. Now I'm going to get the dy dx all by itself by dividing by cosine of y minus x. Cosine of y minus x. So there we go. And then I get dy dx equals y minus 1 over cosine of y minus x. And there you have it. That's a cosine, not an r. When you're typing stuff into Khan Academy, you should use parentheses. But that's the answer. I'll put parentheses around it. Sweet. Hopefully this is not too bad. Let's do a third example here in this same video. I'm in the day. I'm gonna freak out. What's this? I know some of you are gonna freak out. But let's just think about this. Let's take it slow. Assume that a is a function of b. A is a function of b. All right. Maybe look at this and think, what's my main variable? If you can answer that before I answer it, you are paying attention. That's good. In this case, my main variable is b. because it says dB. I'm taking the derivative with respect to b. So b is the main variable. That means when I take the derivative of b, I can do it normally. But whenever I take the derivative of a, I'm going to take it normally and then tack on a dA dB. Alright, maybe you should try this real quick. We have a chain rule here, and every time and then a product rule on the inside. Ooh, okay. Because a is a function of b. Both of these are variables. They're not constants. Both of these are variables. So let's see what we have. First of all, I take the derivative of the natural log. That's just 1 over x, usually. However, I don't have x. Here I have ab. So it's the derivative of the outside with the inside the same. So 1 over a times b. That's the derivative of the outside with the inside the same, times the derivative of the inside. And that's product rule, so I got to put parentheses around it. First is a, second is b. Those are both functions. First is a, first d second. Well, the derivative of b, since b is my main variable, the derivative of b is 1. First d second plus second, which is b, d first. Oh, that's the derivative of a. A is not my main variable, so I take the derivative normally. Derivative of just a variable is 1, but I'll tack on a dA dB. First d second plus second d first, and then equals, taking the derivative of a, that's 1, times dA dB, or just dA dB, and then b is my main variable, so I'll just use the power rule, 2b. And once again, I'm going to be solving for dA dB. I'm solving for that derivative there. Let me simplify this or write it neatly. I'm trying to get the dA dBs by itself. I guess the first thing that I noticed that I could do is distribute there. So I'll do that. There we go. And then I think I can cancel some stuff out. That's nice. So let's do that. And then I get this. Now I'll get the dA dBs to one side and everything else to the other side. dA dB minus dA dB. So that goes away. And then I'll subtract the 1 over b. And what do I get? Well, here now I can factor. Now I'll factor out a dA dB. So well, I'll just write dA dB on the outside times a 1 over a and then minus 1 equals 2b minus 1 over b. And then I just divide by 1 over a minus 1, right? So I'll divide this by 1 over a minus 1. So, and we can leave our answer like this. Just put parentheses around it when you're typing it into Khan Academy, and you should be fine. I know a lot of people are going to mess this up, so practice hard, and then we'll see. There you go. That's the answer. The A, the B. That's the derivative of A with respect to B. B is the main variable. Wow, that's nice. Is it? Not really. All right. Bye.